So with this, now we again now we restart with the frequency concept. Whenever we understand the transform basically the conversion of a uh, signal information at time level into a frequency domain. What you can see here on the x-axis here, it is a different frequency. On the y-axis, it is the magnitude of the different frequencies, that which component is present and what is the strength of that component. Why we are telling the graph Fourier transform? Because it is basically of the graph signal. Now we compare the concept, see how, because remember it's a very interesting concept that for a graph signal we are also able to drive out the graph Fourier transform. Now we compare with the classical frequency filtering. Classical frequency filtering involves designing filters because once we have defined the frequency concept, then filters also comes in picture. The classical frequency filtering involves designing filters in the frequency domain. See, for example, you want to limit out some frequency, low pass filter. If you want to limit the if you want to select out the high frequency only, then you use basically the high pass filter. If you want to select out the middle frequency, you use the band pass. So this is the one. What we want to say that once the frequency concept has been defined, then the filters also come into a picture. What we are saying here, typically using rational functions. See, what are those, how these filters are defined? Again, see, you would have seen the different functions in our classical DSP to achieve desired frequency responses for signal. As we have discussed, the filters can be categorized into low pass, high pass, and band pass, each with a unique frequency response characteristic. So what is actually going on in the classical Fourier transform? What is the base there? As we discussed it, it is basically the Fourier, it is an exponential base, complex exponential basis. Multiply with fx dx, right? This is the one to f cap omega ej omega x d omega. What we are saying that after the applying f transform, it has become f cap omega, and then after applying g cap omega, it has become g cap omega f omega. What is this? This is basically when we are saying it is basically at a filter level, or when we are doing basically convolution. When we convolution, it is this multiplication, and then when you take the inverse Fourier transform, it is basically the this is the in frequency domain it is multiplication, but here it's a convolution. It is the same thing you are saying. But remember one thing, that when we are applying this relation, so we are we assume this convolution thing holds only for a LTI system, linear time invariant system. Now coming to the part graph spectral filtering. See, remember one thing, that once we have defined the frequency concept, the people find it very interesting to extend all the concepts of frequency in the classical DSP to the graph signal processing. So now this another concept, graph spectral filtering. Graph spectral filtering, what is this? Again, see spectral related to frequency. It is some filtering in the frequency domain. Refers to modifying the frequency components of a signal defined on a graph by applying a filter in the graph spectral domain. So even if you see this thing, see what is this G cap lambda L? This is basically a filter. Whenever you apply, how do you apply the filter? Again, by multiplying that filter with the frequency domain representation of that signal. Then what do you do the IGFT? IGFT basically you want to recover back the actual signal that what is happening, right? So that we have done. What type of graph filters are there? This is low pass filter, preserves the smooth, low free, high pass filter, sharp edge or edge in the band pass filter, retains the specific frequency bands. To avoid Eigen decomposition, graph filters can be implemented using Chebyshev polynomials. Remember, when we want to apply it, see, remember, unlike our classical DSP, here when we are applying, so many mathematical models have been given, so that because remember, when you are taking into account the structure, computations uh, increase by manifold. So when you will go through these some research papers, you will find that Chebyshev polynomials find a very less computation based algorithm. People have drawn the equivalent mathematical models. It is not coming. Otherwise, if you will really go by the normal your eigen decomposition mathematics, it becomes too difficult. You would be thinking, see, from where Chebyshev polynomials. Here again, mathematics has come to reduce the computation. It will almost provide the same approximate view. Graph transform dictionary design. What do you mean by the transform dictionary? Transform can be and dictionaries can be designed through graph spectral filtering. See, again, these are basically the filtering operations that functions of graph Laplacian. F is basically when we are doing it, graph Fourier transform. What is this? This is basically this is the transpose of the eigenvector multiplied by the F, right? Thereafter, we are applying some filter. This is G cap. When we have multiplied the filter, then we are taking the inverse graph Fourier transform. We want to see that what has happened in the to the actual signal, to the actual graph signal, so that we are interested. So there people, remember these are the concepts which had been defined, but they are still to be applied in the different contexts. Very good thing regarding these functions that these functions are available in the GSP toolbox, in the MATLAB as well as the Python. There you can directly use those functions and you can see the interesting results. Because it is your flexibility when you design your signal, when you basically represent your signal in the form of the graph. It is our choice that which thing do we want to take as the edge. It is how much weight we want to give. So these things bring out very uniqueness in the graph signal representation. And once anything is represented in the form of the graph signal, we are able to apply the different type of functions. Different type of functions like the graph Fourier transform, like the graph spectral filtering, and we are able to see the impact. Remember, impact is not that regular one. Please keep one thing in mind that the concept which we are reading now, that is the theoretical concept. But what would happen to the reality? What would happen to the actual problem? That will be based upon that will be differ from case to case. And here, that's why I'm saying it's a lot of potential to see the new thing with the help of these graph techniques. We say graph signal processing based technique. GSP for defining convolution on the graph. See how, remember, convolution is a simple operation. What we are seeing, but how will it take place when we will define the convolution on graph? Classical convolution, see, it is seeing here that it is there, ft minus tau. If you recall, t minus tau is basically the shifting version, flipped version, and then you have multiplied it in frequency domain into a multiplication. But here, what is happening? Here, it is not time domain, it is a spatial domain, because all the vertices are represented in the spatial domain. What we are saying here f convolve with the g. So what is basically g here? G is basically represented in form of the eigenbases and eigenvalues. So it is g cap L f. In the graph spectral domain, this thing looks like this. Remember, these are the proposed concepts. Don't think that these things have been derived, but people have presented these concepts. They are still to be applied. That thing must be very, very clear. Learning a non-parametric filter, the diagonal convolution express no localization in the spatial node domain. So there are some disadvantages also when we do this. Localization facility access is not available. Thereafter, what we are doing, uh, remember different mathematical notations have been used. For example, parametric filter as a polynomial of Laplacian. It can be written into this form, and this way we are able to reduce the computation. This is one another very much high cited paper. Convolutional neural networks on graph with fast localized spectral filtering. Again, see, this paper has been cited by more than 10,000 or 12,000 times. There also the people have represented some, taken some images, taken some signals, and then they have carried out the convolution on the graph. Remember, it is case by case approach only. I am reiterating that full mathematics has still not been developed. It is only the uh, formulated notion that this was the case in the classical DSP, this would be the case in the graph signal process. So see, one of my student, Ram Nivas, he has basically implemented. So that thing has been shown here that how the people have applied on the EEG signal. EEG is a basically one-dimensional signal, and one they have obtained the graph signal, assign edge weight by Gaussian kernel, calculate Laplacian eigenvector. Why do we need to calculate Laplacian eigenvector? Because remember this thing to what was the graph Fourier transform? If you recall, it is this one, XL. This is the your eigenvectors only, XL there. What we are saying, this is basically a dot product, or this is in the space we are written it. This we just calculated Laplacian eigenvector. Once you have calculated Laplacian eigenvector, then multiplying with the signal, you are able to find out the Fourier transform, discrete Fourier, graph Fourier transform, or the both are same, graph Fourier transform, graph discrete Fourier transform. Thereafter, see, once we have this value, then you need to extract out the feature, that which feature you are interested in. Then you can calculate the desired features. It is power spectral density, or it is basically energy, because these concepts are available in the frequency domain. Then you use classifier or algorithms for classification. basics of GCNN. Basics of GCNN. Remember, a separate field has come in the deep learning, which is what we say, that is graph convolutional neural network. What does this say? It is say that two type of models are there: spectral based model, spatial based model. In a spatial based model, you use classical CNN based model and propagation based model. Regarding application wise, you can use it in computer vision, natural language processing, science. In computer vision or image processing, it is used as in images, video, point clouds. See, whenever you are seeing any this uh, image, video, first thing should be the come in your mind that what would I take as a node? How would I define the edges? What would be the strength of that edge? So, because once you are able to represent in the form of the graph signal, then all the tools you can apply using the this toolboxes in the MATLAB as well as the Python. So in science, it has been shown here. So what has been shown? It is physics, chemistry, biology, social. So in science, it has been applied because there also you are representing things at the collective level. So what do you mean by the predictive approach? Predictive approach means again that we are basically trying to infer the things from the EEG signal. For example, in this again, see, this is a our uh, research work of my student Ram Nivas. What he has done, he has taken the EEG signal, he has band split it, and then graph construction, and then feature signal. Thereafter, then classifier, and then you are able to predict that which emotion is there. It is exactly the convolutional, it fits there, but only thing is that the initial convolution is basically the graph convolution. Summary of the GSP. So what is the key thing here? Key thing is basically frequency. How do we get the frequency? We get the frequency with the help of the Laplacian matrix. Laplacian is equal to D minus W. So what are those frequencies? Those eigenvalues are coming as the frequency. What is the role of the eigenvectors? Eigenvectors are basically the bases. Because two things are required in the transform. One is basically the frequency, another is the basis. So here eigenvectors are the basis. So thereafter we can say that all the generalized operators like the filtering also, like the graph signal is good at capturing structural properties. What do you mean by structural? It means that the some neighborhood information can be very well taken if we are able to represent the signal in form of the graph. Applications, video and image problem can be structured as graph. So in image, you can take one pixel or you can take group of pixels as a one node or the vertices, and then you can represent as graph. Another thing, represent object structure as a graph or temporal evolution as a graph. See, not only the spatial domain, but also in the temporal evolution, you can take a graph. So how the values basically are changing. Deep learning on graph is starting to become more prevalent. As soon as these techniques have come where you have used this GCNN, so deep learning is also facilitated within very few iterations. Create robust method by denoising signals on graph. So not only we are able to do the deep learning, but also see we are also able to filter out the noise. Filter out the noise uh, with the help of the different filter. So these are the references, what you can see here. Any question if you have. Whatever questions you feel it free. So if you don't have any question, we move to the another topic where the application of GSP at the EEG level, right? So whatever the concepts, remember those concepts have been proposed and it is assumed that uh, we would we would able to see, remember all these concepts have been proposed and all mathematics have not come out. Only very some concepts have been come out along with the application. So it is becomes very interesting when we apply these things because it depends upon the result, that what result you are getting and what is the interpretation. So before starting with a new topic, at least to make the conversation, to break the ice between participants, between myself and you participants. So can you please type your research area where you are working, or what is your motivation that what you are going to learn, means what do you want to learn from this workshop or whatever thing, so that it can be clarity and I can orient my lecture towards that side. Because when very less questions are there, then definitely uh, it takes time, but how can I orient my lecture better towards your objective? So please type your research area uh, and if something what you expect to get from this workshop. I'm waiting for your response. I'm here only. Your research areas as well as your objective. What is your objective? If you are a research scholar, then definitely your research area will be the key thing. If you are faculty, then what means what you are thinking, how is um, what is your expectation from the workshop, what you are going to gain, whatever thing, means it is not necessary, but only to make the things bit open. Because only very few participants have participated. I'm waiting for the 2-3 minutes so that Krishna, Srija, Ruchi, Devashish, Joseph. Okay. So someone has saying, please provide some material to basic knowledge. This topic is very new. Definitely, see, material will be provided to you. All the see, these PPTs will be shared with you. Don't worry about that thing. Signal processing, particularly speech, I joined to gain insight into being signals from perspective. Definitely. See, in deep learning, see, yes, that will definitely provide you. What about others? Speech is a one-dimensional signal, EEG is a one-dimensional signal. So whatever function you are applying on the EEG, you can same apply on the speech one. Different type of filter you can apply. Devashish, many participants have not responded, I think. Neha, Vimal Prakash, Devashish, Joseph, Bharat, AM Shah. So, one more minute. Otherwise, I will see. Only thing is that if I will continue, definitely I will. I will continue. But how can we make our interaction more better? That is the key thing. Because in the classroom sessions, it's very easy to find out the objective. It's very fine to tune the things with respect to. But in online, it becomes because especially when we have the topics like the DSP, your things have multiple aspects. But see, what is in my mind that in DSPC, the things becomes people at one point of time, myself also, we find very, we say, saturated with mathematics, etc. And in research, you need papers, you need outcomes, different outcomes. When I had been working on the graph signal processing, I find the middle way. No, it is not only see, it's very good actually balance between mathematics and the application. So you can work on both the ways. And remember, not only mathematics define everything, but when you go to the application, some new mathematics concepts emerge. That is the beauty. So during my journey, I found when I found that balance approach, so that I wanted to share with the other participants. Otherwise, at one point of time, see, I also found it. See, what would I do in the signal processing when everything has been there, Fourier transform, etc., etc. These things are there. Everywhere it is be surrounded by the ML, machine learning, deep learning. So how can I contribute being a signal processing engineer? So when this thing was in my mind, then I began to explore and see many areas. Signal processing is at such a level, but unfortunately, you will not find many people now who wants to go into the signal processing. That is the key thing. That's why if in my last 10 years, I hardly able to join any signal processing workshop because nobody is interested to organize it. So between the thin line of the ML and mathematics, the signal processing is there. Oh, anyway, so okay, so we will now move to the part another application. Now the application of the GSP, GSP is basically the EEG, right? At any point of time, whenever you have the questions, feel free towards asking it on the mail or wherever you feel it. Because and keep the one goal in your mind. See, whatever we are learning, whatever signal processing, remember they all are not. They can be applied at your research level, or they can be discussed. They can be understood. See, what is this new? इस एप्लीकेशन में क्या नया है जो पहले नहीं था? See, try to explore it. It's very interesting. It's very interesting. See, once you will go through it. So now begin with our application. So easy. First, I want to tell you. See, this is basically primarily work done with my research scholar Ram Nevas. He has basically advanced it because initially I explored the GSP into the concept of facial expression recognition. He advanced it into the EEG signal. So EEG, you have already gone through it, but in context of the GSP, how will we go through it? So just going through it, right? So are you ready? At least you can respond yes or no. So at least I am aware that here is no any automatic signal. Some human is there only. So please respond yes if you are there. Okay, Krishna is there. Only Krishna is there. What about others? Yes, Anand is also here. Anand is actually uh, he is my recent student, youngest PhD student. What about other Devashish? Other names are there. Hopefully, I would be interacting with humans only, not with the simple terminals, not with the simple mobiles. So please respond yes. It is very important in today's attendance. Only Krishna and Anand. What about others? सर्टिफिकेट भी सभी के मोबाइल्स को ही मिलेगा, सभी के लैपटॉप को ही मिलेगा उसमें. Okay, Suman is there. Okay. Yes, yes, all Sumans are very active. One Suman is my student. She is very active. Yes, at least 4 people are there out of 12. But what about another 8 people? Devashish, my research is device with signal processing. See, device, Devashish, which device? It is VSDL or what? In IoT domain. One is Internet of Things. Okay, good. Devashish, in which device you are saying basically? Is it electronics, VSDL, etc. application? So one in IoT domain, Ajay, you are a researcher scholar. So what you are doing? Okay, TFET. Okay, TFET devices. Fine. Some more participant. Neha, are you? Vimal, Prakash. Only to ensure that I am really interacting with the some active processor, not with some automatic processor. Right? That is the key thing. Joseph, Gloria, Joseph, Bharat. So hardly I am interacting with 4 people. Where are the other one? So only terminals, login. Anyways, yeah. So I can just wait so that it will be confirmed that people are not here in another 2 minutes. I will also wait and I would continue this exercise. Remember, attendance also will be based upon these random inspection. Otherwise, for those who are not present, I will certificate will be given to their mobile or their laptops. So we will conduct this 2 minute exercise very frequently. AM Shah, okay, is biomedical engineering. Okay. So in biomedical, see, you will find it, GSP, you will find very, very useful. Why in biomedical? Because in biomedical, all the actually our signals, it's our system, all the signals are uh, interconnected. See, for example, I'm talking about this hand, right? When I am when I'm when I'm talking about this hand, see, for example, this hand is there. For example, the gesture recognition or the so all these points, see, every point is in a neighborhood. They have some relation to this one. Biomedical, all the biomedical signals, they are collection of the nodes, vertices. Their signals have some intrinsic relationship. So that is very, very useful. GSP is the key thing. If you don't know anything in the signal processing, simply pick up the GSP and see the papers in the GSP in your area. Has GSP been applied or not? And begin to apply it. I'm telling you, you will able to find a way. Apart from AM Shah, so okay, so this exercise only these people are there. Joseph, etc. I will conduct this exercise again after 15 minutes. so that it will be ensured that whether only machines are present or the machine operator is present, right? So now continuing with our part EEG. So now see, continuing with this work, as what we are saying, this is introduction brain lobe. So what is this? This is the GSP in context of the EEG signal. EEG signal where? It is basically the brain signal. So introduction. So as I just discussed it, that AM Shah, he is told biomedical. We are telling, see, what we are saying biomedical signals, it is basically number of points. It is can be defined in the two parts. Number of points used to collect the data. Number of points used to collect data and type of potential. Signal which vary with the time. Single valued signals, temperature, pressure. It is action potential signal, is an event related potential. Again, the different type of signals are there: EMG, electroneurogram, electrocardiogram, electroencephalogram, which is the location basically. Cardio, which are basically from the heart, neuro at the neuron level, myogram at basically the joint level, encephalogram at basically the head level. Event related potentials are there. So this is the basic bifurcation. Biomedical signal. Now coming to the EEG part. In EEG, measures the neuronal activities, means it is a continuous recording of the electrical activity of the brain by placing the metal electrodes over the skull. It basically identifies the health conditions especially regarding the brain. EEG analyzing the electrical signals in the brain. Electro, right? We use electrodes here. Many ML algorithms are used for many analysis methods. Specific machine learning methods used for EEG analysis. EEG analyze on both frequency and time space. We measure the voltage fluctuation measured by EEG. Can somebody tell what is basically the voltage of the EEG signal? When you will go through it, it is basically in very, very small. It is the microvolt, right? So when you will see it, that's why very, very sensitive electrodes are there. Yes, absolutely. Voltage flux, so voltage fluctuations are generated by ionic current present in the neurons. 10, yes, it is there. 10 to 100 microvolt. That's why very, very sensitive devices are there. And remember also one thing, what is the beauty of the EEG? That see that our all the functionalities are related with the brain. Whatever changes takes place, that will go through the brain. So if we have the very good sensitivity of the EEG and the all are correlated to each other. So we are able to uh, find out, we are able to extract out much more information from the EEG signal. Again, continue with the biomedical signal. It is EEG analysis using graph signal processing. In this part, what we have done, EEG analysis using ML. See, graph signal processing will allow you to extract the feature. उससे आपने सिग्नल को रिप्रेजेंट कर दिया, सिग्नल को रिप्रेजेंट करने के बाद आपने उससे फ्रीक्वेंसी डोमेन में कर दिया, फीचर्स आपके निकल गए, बट फाइनली व्हेन यू डू द क्लासिफिकेशन, it is used basically the machine learning. So machine learning is an integrated part for the research. हम ये deep learning use नहीं कर रहे हैं क्योंकि deep learning requires lot of data. So machine learning is used, and in machine learning, so in the supervised learning, it may be two type. Again, see, you people would have gone through it. It's classification and regression. Regression basically where you predict the thing. Is ethical permission compulsory work with biosignal acquisition? How to bypass it? See, remember, there is someone, see, one thing is there is, see, two things are there. See, ethical Permission means basically when you are taking somebody's data, identity etc. don't needs to be disclosed. That is one primary thing because it is their individual data. So that's why see one committee is there that for the research purpose, these permissions are granted. But again for the very sensitive data. So what we say in a big hospitals etc. So there they already have the framework that for the research purpose you can use it, but without disclosing the identity of any person. So there is no way to bypass it. Already some mechanism. Why do we need to bypass it? Only you need to collaborate with the good hospitals or with the uh, or you can collaborate with the good doctors. For example, we are also trying to develop a mechanism for internet addiction using EEG signal. So here no more any such ethical permission is there, but we need some doctor. Even on the Sunday you will have lecture from one industrial expert. They will tell you that how for the basic applications, for the basic classification, not such any medical disease related, ethical frameworks are not very difficult. All papers are rejected as ethical permission is not with us. See, because it is required, because the data, this is a very key thing. Ethical permission means, otherwise, see, two things are there. One is basically whether your data is adequate enough, whether your data is proper one. Because ethical thing, because when you are taking any biomedical data, see, primary thing is that it should not violate anyone's right. So we should never ever try to bypass any mechanism, right? So we will uh, talk about that thing on some way, but best thing is there to collaborate it in your neighborhood, at your college level. You can see that where people are interested in the common research. That is not very difficult. Coming to the unsupervised learning, and unsupervised learning, here you basically make the clusters and density reduction. So here see you don't need to basically tell that this thing is basically training testing. You can basically make the clusters. When there is a lot of data is there, then unsupervised becomes very useful. In EEG analysis, what do? You do basically pre-processing, feature extraction, feature selection, training and testing. Here we are basically used mainly the ML algorithms. Why ML algorithms we are used? Because if you see in the Python and the MATLAB, very good, almost all the good algorithms are supervised one because of the availability of these methods. And being electrical engineer, see, I don't have much more time to develop the another algorithm. So whatever is available, we want to use them in a best possible way. Now the basic flow chart. See what happens. See what happens in the reality. How the signal processing, machine learning. Because remember one thing, key thing in the research, that once you are aware about the actual flow, what is going on, things are very simple to analyze. So what happens in the computer assisted diagnosis? One patient is there, it is biomedical signal, whatever is there, some transducer is there, then preamplifiers, you amplify and filters are there, analog to digital conversion is there. This is basically the data acquisition. Thereafter, what you do, you basically do the noise removal, you do the detection of events and components, and thereafter you do the feature extraction. Remember, three steps are there: signal data acquisition, signal processing, and signal analysis. Here you feature extract, there pattern recognition, classification, and diagnostic decision. When you do basically recognizing the pattern, here physician is required, because see, it is not only from the one or two patient that we can generalize the result. That's why medical people intervention is very much required. Classification, here in the classification we use basically ML etc, and this is basically computer aided diagnosis and therapy. Motivation. So What is the motivation to go through the EEG signal? It is basically necessary for early detection and diagnosis of the epilepsy disease. This is the remember key thing. पूरा जो मेडिकल दुनिया में जिसने पूरा चेंज ला दिया कि एपिलेप्सी को हम ईजी सिग्नल से पहचान सकते थे, राइट? तो दैट पीपल आर डूइंग इट। इतना सक्सेसफुली लोगों ने डायग्नोस किया। यदि आपको रिकॉल आपने किया हो कि जब व्हेन पचौरी सर आल्सो हैड बीन डिस्कसिंग that when the attack of epilepsy comes, it becomes very, very difficult to control the patient, right? So its early detection becomes very crucial because then the medicines, etc., can be given. It used to investigate some other condition like the head injuries, brain tumors, dementia, hemorrhage, determine the level of the brain function in people who are in coma, identify the area of brain that are not working properly based upon the book, to analyze the human behavior by emotion classification based on EEG signal. See, how do you basically, why it becomes important? Because see, normally people identify the emotion from the facial expression. But many times when some person is under some supervision, or for example, like in criminal behavior, whether the person is lie detection, then people do the fake smile. People hide their actual emotion on the face. In those cases, EEG signal becomes very, very crucial. Identify the early sign of insomnia, narcolepsy. So these things also becomes very important. Now coming to the part of signal processing part, feature extraction and feature selection. Basically in the feature extraction, two approaches are available to perform dimensionality reduction. Feature extraction, you creating a subset of new features by combination of the existing features. So what is the basically one? So here if you are seeing in feature extraction that x1, x2, it has been changed to the another variable y1, y2 to the yn. How they have been changed? You have applied some transform, you have applied some function. It can be anyone. In the from the previous slide, previous session, what did we observe? That it was basically the graph Fourier transform. In graph Fourier transform, when we applied it, it was feature extraction. What do you mean by the feature selection? It is the process of selecting a subset of relevant features. So, what type of selection you are used? Many times it is basically PCA. In PCA, you use basically the you select the key features. Why feature selection? Because see, to remove the irrelevant variables or noise, to reduce the computational complexity, reduce overfitting, and increases generalization capacity of the model. Apart from a dimensionality reduction, it can be supervised, unsupervised. In unsupervised learning, paradigm data are analyzed based on their inner structure. For supervised learning paradigm, we also utilize class labels. Dimensionality reduction is different from the feature selection. How both methods seek to reduce the number of attributes in the data set. But feature selection is the process of selecting a subset of relevant features to use in model construction. Dimensionality reduction combines features to extract a new set. Here you don't pick up. Remember, these type of question can be in your quizzes. These type of important things. Type of feature domain. Features based on the time domain, features based on frequency domain, features based on time frequency. What do you call the time frequency? Is somebody able to recall what is this time frequency? If you all are from signal, those who are from signal processing background, they will not find it difficult. Time frequency is basically wavelet. If you see, where both the information is available, time as well as frequency. Now coming to the part in this one, in brain lobe. So what we are saying here, anatomical. So see, brain. See, as we are seeing, all EEG is related with your brain part. As we are also, if you recall the earlier slide in GSP, that we considered the brain as the graph signal, where your structural connection is the edges. So here structure makes a lot of difference. So what we are seeing here, so someone is asking how the frequency content of a signal changes over a time. See how the frequency content of a signal changes over a time. See what is the key thing in the wavelet that it see at see overall see what happens in the frequency domain. We are able to know that how many frequencies are present. But at what point of time, what is the, if, see, for example, I am taking a 10-minute interval. In 10-minute interval, I want to see that at fifth minute, what is the composition, which frequencies are present. That is difficult to know from the frequency domain. So when we are, so how, so frequency content, see, overall frequency content remains same, but at some particular point of time, if I want to know the exact frequency, then it is difficult to know from the frequency domain. That at this point of time, maybe they had come over later point of time, another frequency, but at this point of time, it is not necessary, it is not a constant behavior. It is not that that frequency is present. Because your signal is also varying with time, no? So that's why we say. So frequency content basically, so someone only one thing that at some point of time some frequency are present, at another point of time another frequency are present. They have emerged over after that point of time. That is the thing. Now see when we coming to the structural part in this frontal lobe, it is what we are saying thinking, memory, behavior and movement. That frontal part is there. Parietal lobe, this is language and touch. Temporal lobe, this is between the side. This is occipital lobe, side. Brain stem, breathing, heart rate, temperature. Cerebellum, balance and coordination. See, you would be, it is interesting to know, जैसे when people are in the accident, when people have the accidents, when they different injury, based upon the injury, people have these that much insight about these things. किसी के मान लीजिए इस पार्ट में इंजरी हो गई तो हमें पता लगता है कि उसकी बाकी सब ठीक है, बाकी बिहेवियर ठीक है, बट ही इज अनेबल टू रिकॉल. किसी को क्या प्रॉब्लम हुई, बिल्कुल दैट पर्सन इज एब्सोल्युटली वेल, बट ही इज नॉट एबल टू स्पीक प्रॉपरली. So that way people are able to find out these relations. And remember, this thing is again very, remember there is no such any clear boundary. जो हम ब्रेन में अभी जो हम डायग्राम देख रहे हैं, इट्स अ वेरी वेरी सिंपलिस्टिक वन. अदरवाइज यदि ब्रेन सी इट इज द लास्ट ऑप्शन कि कोई किसी का दिमाग इट्स ओपन सेट, बिकॉज देर इज नो वे, इट्स मोस्ट कॉम्प्लेक्स नेटवर्क. तो हम क्या करते हैं, सो अगेन सी it is one way only. You can't basically, until except emergency situation, nobody is ready to redraw these loops. So that's why we people believe in analyzing the things and then giving the treatment. Data acquisition. So we will in one session we will see in the detail that how the data is taken. Basically on the Sundays, our session we will see it. What is the data acquisition? Against the subject is, yeah, there are different electrode locations are there, publicly available data set, tasks are there, and psychological experiment building language is there. So these are basically the points where your electrode cap is basically placed, right? So depending upon it is 32 point, it is 64 point, 128 point, you can take the different. On Sunday's lecture, we will try to demonstrate you by one industry person. Now, see, coming to the part easy rhythm, again, what type of signal is there? Here, see, frequency domain becomes very important because different frequencies are present. For example, delta wave is there. When you are in the deep sleep, it is the minimum frequency, right? Lower frequency. So this is the one where brain is almost at rest. But remember, brain is working. Theta waves, it's in a normal sleep. See that's why we consider that when we want to analyze the insomnia or the sleep analysis, EEG rhythms becomes very, very useful. Because how much deep sleep your mind has got, that will be aware from the EEG recording. Theta waves as from the normal sleep or the meditation part. Alpha wave. Alpha waves is basically 8 to 16 hertz when the person is actively working. When the person is in alert mode, then it is the beta wave, 16 to 32 hertz, and it is a gamma waves when it is a mixed one. You see very much fluctuation at the mind level. You see that's why we people have been asked to do the meditation. Why? Because see, you can see these waves. More relaxed your mind is there, more means better you are able to take the decisions, etc. But if you always remain overburdened with tasks or you are basically hypersensitive, then these things become the issue. And that is the key thing. How does the meditation work? It brings you into this state. Even see, this is the key thing that when you are in the deep sleep, that's why sleep is essential. Your brain is able to nourishes every cell. Otherwise, in this state, this is the key thing how the sleep becomes very, very why sleep is very essential and why meditation is essential. All the researchers, what you are doing, I would suggest you to go through the meditation, even for a 5 minute, even for a 10 minutes, because it makes a lot of difference in your efficiency of the brain. We would discuss someday when we have the time on the meditation which I follow. So now the EEG data flow. In EEG data flow, see what we are saying. See again, whenever you for all the signal processing students, see key thing whenever you see any data, the flow chart is a key thing. So what is happening here? Data acquisition is there and amplification, then signal pre-processing and artifacts removal. Thereafter, you are extracting feature and you are selecting feature and then classification model training and then performance evaluation and implementation. This is the key thing for the brain computer interface, right? So time domain features, right? We have told this, we have basically divided the features into the three parts: time domain, frequency domain, and time frequency. So in the time domain features, see why the features are important. Features are important because those features you need to extract out from your signal. So the statistical feature, entropy measure, the number of zero crossing. What is this number of zero crossing? It is basically the same frequency. Band power. What is this band power? Again, the alpha band, beta, gamma, theta. What happens in the frequency domain? See, both signal is available, but how will you extract out this thing? तो दिस इज पावर स्पेक्ट्रल डेंसिटी. जब भी आप देखेंगे किसी भी आप रिसर्च पेपर में देख रहे हैं तो ये देखिए कौन से फीचर्स यूज हैं, क्या उसने यूज क्यों उसने यूज किया उस डेटा में. तो पावर स्पेक्ट्रल डेंसिटी, वेल्च मेथड, इंटेंसिटी वेटेड बैंडविड्थ फ्रीक्वेंसी, मीन मीडियन फ्रीक्वेंसी. Time domain, as we discussed, it is basically wavelet. It is short time Fourier transform. It is continuous wavelet transform. Shoei-Williams distribution. If you see yesterday in the Pachori sir lecture, see another feature he had been using EMD, empirical mode decomposition, IMD, intrinsic mode decomposition. Again, see they are basically the modifications of these features. जब भी आप रिसर्च पेपर को देख रहे हैं, whenever you are seeing it, after seeing the accuracy table, after seeing the result, you need to find out which features are used. Am I able to find out those features? EEG signal. Now, EEG signal is basically used at two level at neurological disorder. It is basically GSP based approach. It is machine learning based approach because see, we will see we will see the difference between GSP based approach and machine learning based approach. Another monitoring application here, GSP based approach and machine learning based approach. See, but remember key thing that even when we are using GSP based approach, we are not denying that we are not using machine learning. We are using machine learning. But here when we are saying the machine learning, it means it is without GSP. But GSP based approach means doesn't mean that it doesn't contain machine learning. Machine learning is definitely will be there. So any question? Tell this. The master thesis someone has. I have taken EEG and EMG data during yoga position analysis using fractal dimension based analysis. Very good. So what type? So you would have been. So what was your objective? What is there any binary classification, impact of yoga or anything more? Suman? What about the other participants? Again, my 2 minutes check whether it is uh, machine or the machine operator who is present here. Please respond yes if you are here. 1 minute. You'll maximum take 1 minute if you are here. Yes, Suman A. M. Shah. Only. Devashish, okay. Fortunately, Devashish is also, yes. Krishna is there. Okay, 4, 5. So we can say it is 1, 2, 3, 4, 5, 6. At least 50% are machine, are operator, but 50% are still machine. That is thing. Anyway, see, we come to the part here. Different steps of analyzing EEG signals. So what we are saying here, different data collection methods in the form of publicly available EEG data sets, other local data acquisition studies. See, whenever you have the chance, whenever you want to start the research, finding neural response, okay, based on vector classification using this vector domain, okay. So see, what we are saying here that in the different data collection methods, so analyzing EEG signal, what you do basically the processing means it is pre-processing, it is feature extraction, it is post-processing, it is result analysis, right? This is the thing. Because see, why are we mentioning? Because regularly we say that we are analyzing the EEG signal. So what do you mean by the analyzing of EEG signal? It means that thing. It is downsampling, it is feature scaling, it is feature selection. So, and finally, result analysis. Here, it is basically your machine learning. Please remember, machine learning are the key part. Nobody can avoid it. Basic approach to analyze EEG signal. See, this slide is very useful. Those people who are basically begin to go deeper in their research. So what we are saying to analyze, it is neurological disorders. This is basically the need and prediction. What did we say? That either you can use a machine learning approach, you can use a deep learning approach, or you can use the graph processing approaches. Here, when you use this approach along with the approaches, you work upon the EEG data. In the graph processing approach, here you work upon the brain medical images, fMRI, CT, MR, PET, EEG, along with EEG. Because your graph processing can is also very useful for this one. Thereafter, you do the pre-processing. Pre-processing here is not compulsory for the DL data. Only it is for the machine learning, but it is very useful in the graph processing. You remove the noise, you remove the artifact. Then feature extraction in the DL, it is automatic feature extraction. While in the machine learning and graph processing, it is a time domain, frequency domain, and feature selection and classification using ML. See, please be clear here one thing, that even when we are saying that we are using the graph processing approach, we are not denying to use a machine learning application of EEG signal. Again, see, it is the same thing that public, it is epilepsy. Already we have discussed it many times. See, why we are mentioning, you would be thinking why we are mentioning these applications, because based upon application, you can have the different type of analysis. Same data set, same data set, same technique, but with a different application, you can have the different papers. That's we want to emphasize upon. सेम टेक्निक है, सेम डेटा सेट है, पर एप्लीकेशन अलग है, तो आपके नए पेपर्स निकल सकते हैं. दैट्स व्हाई वी वांट टू कन्वे टू यू application of EEG signal. So starting with Alzheimer disease detection using EEG signal. In Alzheimer disease detection using EEG signals, what is Alzheimer? Alzheimer, as you people would be aware, that the person has the memory loss with the age. What happens? Cognitive decline and changes in behavior. See, what is the concern here, that once the person begins to suffer from the Alzheimer, it basically starts in the part of the brain, and it almost it continuously increases. And at the later stage, it is very difficult to treat it. So what is the key thing? Key thing is only the one, that you can initially diagnose the person, that when it is begins to influence the person. Remember, fortunately, or we can say that in India, actually, data is not much more available. But in Western countries, Europe, see, majority of the people are there who are suffering from Alzheimer's disease. So that's why in India also, when now the data can be recorded, people can be traced. So this thing uh, has been checked, and it has found that it is equally prevalent in the India also. Only it was that people, because we did not record the data and we did not classify the patients, that's why we were not aware. Otherwise, this problem is present. What is here, EEG has become very useful. EEG pattern in Alzheimer disease, it is basically slowing of the EEG rhythm. See, as yesterday somebody asked that, see how we can correlate the EEG behavior with the disease. Somebody asked, I think, to Pachori sir. So it is basically in AD patients, there is a general slowing of EEG rhythm. This manifests as a reduction in the power of fast frequency. Remember, यदि आपकी अल्फा बीटा वो कम हो रही है हमेशा, that is also not good. That is also a problem. Until and unless you are not doing meditation for all the time, that is different story. Otherwise, slowing of easy rhythms is not a good one. Decrease alpha and beta power. Alpha is basically, as we have already seen, it 8 to 12 hertz, and beta 12 to 30 hertz rhythm, found to be reduced in amplitude and frequency in Alzheimer disease patients. Alpha rhythms are particularly important as they are associated with cognitive function. Because remember, your attention, memory, they are related. As they are involved, they lead to the alpha wave. So increase theta and delta power. There is often an increase in the power of theta and delta waves, which are typical as well drowsiness and deep sleep in healthy individuals, but appear more prominently in AD patients during wakefulness. Remember, during deep sleep and drowsiness, it is fine, but during the wakefulness state also, when this becomes this increase, then it becomes a problem. So Alzheimer detections, what we want to say, remember, Yesterday, if you remember, see, I had asked one question to Pachori sir, see, how are we able to basically measure the data, new data. So what did he tell? Ki, see, you can't rely totally upon that data. You also give the questionnaire to the participant that whether someone is suffering from Alzheimer or not. It is not only based upon one test, one EEG test or two tests. You also need to support that data by the another questionnaire. So that also you give it. Mental type patient history, that is saying MR, brain imaging. This is MRI and the PET. One of my students, Suman, is doing basically. So we will also discuss the GSP role in the brain imaging. Medical measurement is this is there. So why this diagram is there? Because Alzheimer can be detected through many things. It can be through memory test. It can be through the brain imaging. It can be through the EEG. It can be through the this CSF test. So this is the data sets, Alzheimer and disease detection. So here I conclude it because see, I don't want, because it's already end of the day. I want we will begin it that what is in the data set. We will begin in the tomorrow. So if you have any question. Any question or any suggestions, you feel free here because whatever can be improved, it definitely you can give to me. This is a this is the best way how we can better design the program, how we what we can do. Yeah. So any suggestion, any question, please feel free to write in the chat box. We have, we conclude the today's session. Nothing more from my side. So no more questions. So we conclude it today. Okay, thank you to everyone. We will study material, some paper graphs and processing. Okay, we will provide it. Definitely. I will provide you the base paper today also. Definitely for basic knowledge, you can go through it and you can come with your questions also. I will provide it today. Thank you to everyone. Thank you. No, no, leave webinar.